Okay. Okay, good morning to one and all. And I'd like to present my topic on the renewable and modern control of power electronics technologies. And I am from University of Southeastern Norway in Porsgrunn City, which is 200 kilometers from the capital Oslo in Norway. So here I like to brief the power electronics concepts what we developed with my team members in postdocs and PhDs, what we work for the past. So we developed some hybrid algorithms based on artificial intelligences to make photovoltaics, wind, integrated as a renewable energy sources for clean energy with noiseless and applications. We focused also on agriculture because that's very important. All these cases, we try to develop maximum power point algorithms under different environmental conditions. For example, we have taken artificial bee colony and we done MPPT algorithms, maximum power point tracking, with a high accuracy and ability to adapt in different environmental conditions. So this is an example of what we have developed with synchronous generator as a wind turbine model. So we have a wind turbine model along with a synchronous generator. Then it is given to a rectifier where we convert all these AC power into DC. And again, the DC power is pumped again to a higher value because the inverter requires the minimum 700 to 1400 or 700. So that we use these power electronics converter to increase the power to a high level. And we control the inverters by using particle zone optimizations along with advanced space vector modulation schemes, and we driven the centrifugal pump for irrigation facilities. We adapted, could you please turn off your mics? We adapted a particle zone optimization algorithm to control the duty cycle of the inverter, and to control the maximum power point we used the ABC algorithms. And in order to track the maximum, is always very important that the maximum wind speed is very important. So different wind speeds are calculated at a different angles in the tip speed ratio in combination with the coefficient of right? So when beta equal to 0, we are maximum having CPC, which is 0.5. The minimum is around 1.2 when the angle is beta equal to 22. This is the basics of wind turbine character. So here we have hybrid, we have wind turbine and photovoltaic systems. They are working in parallelly with the grid, and we enhance the power substantially. For example, we used some hydration because it's a ABC based algorithm, artificial intelligence. So we took 50 hydrations, runtime 15, and we desired our error to be 10 power minus 6. We took some total food sources 20, and employed number of bees is 10, and number of lockers B is 10 because DSpace requires minimum number of data to process in real time. We start the programs. We initialize all these parameters into the systems in the DSpace. We calculated what is the random speed of the turbine, duty cycles, and etc. Then we calculated the fitness function. Once the fitness function is calculated, we are triggering the duty cycle for the Cuck converters. Then we calculated the rotor and duty ratio so that in order to make whether we are getting the evaluated values, and then we change accordingly the evaluated values for the expectations. Yeah, then we are checking the hydration limits. If the hydration goes to the maximum number, then we go to the duty cycle to be optimized. If the number of cycle is not optimized, then we are increasing the fitness function. I also request some of you have turned on your mic kindly. Could you stop because it disturbs my presentation? Thank you very much. About control algorithm is very important because we use very simplified control algorithms for testing these systems. So we take a reference speed from the rotor of the induction or synchronous drive. Then we compare with the actual speed. Then we introduce PI regulator, and these PI regulator values are tuned by using piezo. So PSO is dedicated here for tuning the KP and KI of the speed regulator. From here, we calculate what is a synchronous speed, and actual speed of the rotor is compared to calculate the slip, and we multiply the slip by the gain because we need to increase the amplitude to have a V by F control, which is a lookup table. So for example, if the frequency is say zero point 0.1 in scale, it means 10 hertz. If it goes to a scale of 5, then we say 50 hertz. So we have a lookup table between the frequency and voltage, and we feed to a converter which converts all these two signals into three variables and three variables back to two variables to control the space vector modulation. Because in space vector modulation, we are working on 360 degree of modulation, and every 60 degree is shown here. For example, if I am here to control the more inverters, I will be triggering in this triangle in clockwise or anti-clockwise. This freedom is available in space vector modulation, whereas other modulations, simplified modulations, these controls are not available, so that the power quality and the total harmonic distortion cannot be controlled in conventional modulation methods. So space vector is widely used in all the companies as well as for real-time application. About PSO, what we are doing. So in PSO, we start the program, we calculate the velocity for the swarm optimization module. Then we evaluate the fitness function. What is the fitness function? And we update KP and KI specification. Then we run the motors. Then we evaluate the performances. We find the condition, what is obtained in the real time. If all matches, we end the program. If it is not done, we update the system for the fitness function of the particle swarm optimization. This was done exactly in this block in parallel operation along a very complex speed control we implemented in a minimum scale. And this is an example how we are going to test it in the real time. You can have a look. We took around the PV power, which is 220 watts, turbine, which is 160 watts, 50 hertz, and the rotor resistance, stator resistance are given here with a speed of 1800 RPM. And this is the lab scale model. We use DSpace, which is 1108 version, which is a low frequency or sampling rate processor. But we tried to control everything to the optimized value, and we generated the powers to the grid connected system by using DC to DC converters and inverters, which are working parallelly along with the DSpace in a large experimental setups. And what we are doing here, we are using ABC control algorithms, where the idea of using ABC is to create a duty ratio for a PV-based ABC MPPT algorithm, whereas particle swarm optimization is adapted for current signal processing of the PV and wind. For example, if we have only wind, then ABC algorithm is used only for calculating the duty ratio of the DC link voltage, whereas a particle swarm optimization we use for again current signal optimization of a permanent magnetic synchronous generator. When we have only photovoltaic, so ABC will be taken out of the control. Only PSO will be used in the system, so that it's called hybrid algorithm, because we have two different control algorithms, and we try to utilize each its benefits for different aspects based on our own experience and real-time parameters what we got from the sensors and calculations using advanced scopes from Fluke and Yokohama. We observe various parameters to understand the realistic requirement for industries. And this is a sample example how we are developing in DSpace. You can have a look by using MATLABs. We use master control units for modulations, and we are using extracting the parameter from MPPT. Then we are using ADC channels for calculating the currents and voltages, and we are developing the modulation required for the inverters and converters. And these are sample examples. So you can have a look where we are getting a wind speed variation from maximum to the design minimum value. And this is the wind power. It has a huge oscillation. You can have a look, sub-frequency oscillation or visualized here. And this is the duty cycle, which is generated for the power electronics converter to control all these variations. There are a lot of sub-frequency oscillations are available, but by using the control algorithms and effective filter monitoring system by using LCL filters, we have shown the high quality waveforms under various regulations. The current, we are using batteries, photovoltaics, and wind. The battery current shows very smooth regulations, pure DC. Similarly, the currents which are regulated based on the generator also very smooth. Photovoltaic currents also very smooth. and this is the current from the induction pump, which is used for irrigation purposes. So all these cases, you can have a clear waveform which are generated as per the standards of IEEE. And this shows you more dynamic behavior in real time, because in particularly the photovoltaic systems, this is the voltage generated from the photovoltaics, obviously is a semiconductor devices and having huge subharmonic oscillations generated, and obviously we'll have large oscillations in the current and power. This is a realistic figure what we obtained from the photovoltaics. And from the photovoltaics, we also looking very close variations of these currents and powers, how much they are deviated. But in overall power regulations, say irradiance conditions, minimum to maximum than to minimum, we are getting the power regulation very smooth with a constant power delivery to the loads of induction pumping. And this can be observed here. A smooth regulation of the current is shown here. Only 2 times it has a disturbance because we created practically here, and all the speeds are regulated very smooth with a short time of transient. Then obviously the torque is very smooth with the regulation maintaining the constant load pumping of the water system. With a DC link voltage, as I said in the beginning, we are using converter because we need 1400 volts. And these are the dynamic responses you can able to see from the flow rate of the turbine, the flow rate of the induction pump along with the head variations. You can have a look at how the performance is carried out by the pump. And we are trying to keep the unity power factor. So this is the voltage and the current from the inverter. They are in phase and they also reaches the same value at the peak. So they are almost unity power factor, so that we convey the efficiency can reach to the best possible around 90 to 95%. And this is the DC link voltages and DC link currents, what we got from inverter current, what we got from the real time. And here you can have a look how the insulation has been created in the photovoltaic system from 1000 to 500, back to 800, then to 300, then back to 600. All these regulation, the quality waveform is generated by advanced controlling of converters and inverters by using these piezo's and ABC algorithms. And this can give you further in dynamics. You can have a look how piezo has generated the duty cycle, the controlling signals for the converters. It has a large subharmonics. But when we use a fuzzy logic base, it is reduced a little bit. But we adapted ABC, which is a and colony B algorithm, which has a very finite variations and smooth propagation is carried out. And this can also further emphasize how your piezo has huge oscillations with algorithms, ACO and fuzzy logic and ABC. So all the cases is a proof that we have generated a very fine quality of algorithms by using ABC. And I like to go for another aspects of real-time implementations. This is an experimental setup where we try to incorporate photovoltaic systems, particularly focused on photovoltaics. So photovoltaic systems are connected to the zeta converters and inverters. So zeta converter is a DC converter to increase the power, and inverters connected to the grid. And we used a large nonlinear load as a lamp system intermediate to create a huge power factor lagging load, reactive loads. But by using the control algorithms, we can be able to generate a high quality waveform. For this purposes, the simplified algorithms we use based on hysteresis controllers, and we are trying to control the currents and voltage by using advanced AI algorithms. You can have a look how we try to create a hybrid module of handfist, which has a neural network, fuzzy logic, and piezo combination. And we try to develop by using MATLAB based DSpace, and we have shown the quality of the grid behavior and current behaviors of the inverters, voltage and current behaviors. You can have a look even during the huge perturbation condition, the grid voltage is kept constant and current injected, whereas the inverter is trying to figure out all the disturbance created from the photovoltaic system. These are the experimental results we have been doing in our lab. Since the time is very short for me, I like to give you some application. Also, we worked on smart home applications by using IoT sensors, where we use particle home optimizations, grid connected systems. So there are 4 homes which are connected with photovoltaic panels, and we use IoT sensors to control all the parameters by using particle home optimization algorithms. And we are trying to control the Z source converter, then connected to the load system. So what we are doing, we start the program. We are trying to initialize all the parameters. Then we create objective function for the PSO algorithms. Then we try to achieve the best performance by the search. Then we decide all the estimated parameters are reaching the expectation. If it is achieved, we stop the programs. Otherwise, we try to increase the values of objective functions. So these are the parameters we took for the experimental testings. And we find under various irradiation conditions. You can have a look, the current generated from the photovoltaic. We create a huge insulations so that there is a regulation from a minimum value of your current from 4 to maximum 8. And of course, there is a duty cycle control from the converter, which is able to compensate these losses. And the total power transient happened from the photovoltaic. You can have able to have a look here. So here, until that, we have only 80 watts power, then track back to 200, back again to 80 watts by using the controllers. We try to make a artificial insulation systems. And here you can have a look under all these variations. The power connected to from the delivered to the grid will be always constant. You can have a look, the power which is generated from the photovoltaic, we try to keep constant. Current is regulated based on the loads, and duty cycle varies accordingly. And we are trying to track the maximum power from the photovoltaic systems. And this gives you a clear idea how it has been done with conventional methods, which is called perturb and observe method, where you can see all the voltages and currents from the photovoltaic panels is created very huge subharmonics, which is also available in the powers which is connected to the grid system. There is oscillation. But when we adapt our algorithms, which is modified algorithms by using IoT sensors along with PSO, all we killed out all these subharmonics, and we are making the power quality the best possible. So with this, I like to conclude my presentation. We have developed many power electronics hybrid control algorithms to frame a hybrid renewable energy systems, particularly on energy harvesting towards centrifugal pumps in agriculture. We try to tune all the PI regulators by using PSO algorithms. Then we created a hybrid renewable energy systems to balance the DC link voltages when there is a huge variation in the wind or solar power. Then we used hybrid ANFIS piezo algorithms where we try to track the maximum efficiency from PV. Also, we adapted IoT sensors along with PSO to show that they are environmentally free condition where human access is not required. And of course, we try to provide high quality powers. So these are the investigations we have carried out from our research groups. At this time, I like to thank my researchers, Professor Niranj Priyadarshini, Professor Mahajan Sagar Bhaskar, and Kiran Pandav Maroti, doctor. So they have been with me more than a decades of time, and thanks a lot for their contribution and efforts done in this project, particularly to Professor Neeraj Priyadarshan. Thank you all. If you have any questions, I'm happy to respond.
Thank you, Professor Sanjeev Kumar, for the nice, interesting presentation. From my side, everything was clear. I don't know if the panels have a question. Please, you are free to make a question to the professor. Mohammed, do you have any question? No? No.
Thank you so much. That was very clear and fantastic presentation. Thank you so much for your time, Professor.
Thank you. Thank you. Have a nice day.
Thank you. Have a nice day. Bye. Thank you. Bye-bye. Bye. Okay. The next presentation is me. Please, Mohammed, can you share the... Here the PowerPoint slides and... Good afternoon, everyone. My topic is related to the workshop on solar system simulation and green buildings. And my name is Claudian Donska. I'm the associate professor at Polytechnic University of Tirana. And my topic is focused almost energy challenges in buildings. We can brief introduction, the importance about the challenges that we are seeing every day in our modern life. Firstly, the importance is high energy consumption due to intelligent heating, ventilation, air conditioning system. And the second one is related to the lack of insulation leading to energy loss. The third one is also related to inadequate use of natural light. And afterward, this aging infrastructure requires modernization and some limitation we have for adopting renewable energy sources. We have seen, sorry, Mohammed, can you go back? Okay. We have seen that energy now, after the COVID time, the cost of energy is changing, and also day by day starting to be more expensive. And our focus is just to focus on renewable energy sources and to have one sustainable country with smart cities. Also, our smart houses should be related and focus to the related to renewable energy. Also, we need to pay attention also to the insulation about the apartments, because we have almost 60% of the buildings in all over the world are related to the older system style, and without any good insulation, they are the buildings more than 40 years, and they are consuming a lot of energy. And we need to think how we can make insulation and how we can change almost the things to be the smart, for example, also to change the lights and to find to reduce the energy consumption. Okay, Mohammed, please can. And first of all, we need, as I have mentioned, to focus on smart energy management in buildings. It's very important. We need to implement Internet of Things sensors for the real-time data collection. Also, we need to focus on automated control of lighting and to check also the system of heating and ventilation air condition. Also, we need to predict the maintenance through artificial intelligence algorithms, because now artificial intelligence is very important for everyone to give, also to make the maintenance and to control about energy efficiency. We need to check about the demand response to optimize energy usage. Also, remote monitoring and control via mobile application. Nowadays, everyone, we have a mobile, and also we can check and about optimization, about energy efficiency. Also, optimization of renewable energy integration, occupancy-based energy management. Also, we need to check the data analysis to find what are the most opportunities for saving the energy. We need to check as we are focusing on the standard, international standard always required, we need improvement. Also, in our case, we need to check the continuous improvement through feedback loops. Also, we need to check improvement of bus security through smart system. Okay, Mohammed, let's go. Now, also machine learning can help us for different applications for build energy management. We need to check here. We can see one house that how we can implement the machine learning application in our smart future smart houses. We need to check the load and the power prediction, optimize energy usage. The second one, we need to focus on the fault detection, reduce energy waste from equipment malfunction. Machine learning-based thermal comfort models enhance occupant satisfaction. Till we need also to focus predictive maintenance for minimize downtime and energy loss, because it's very important to check periodically or which part of the houses has more consumed about energy. Also, machine learning can help about that one, and also continuing learning adapts to changing building dynamics. And in the end, it is very important, cost-effective and flexible compared to traditional method. Okay, let's continue. Here is how we can implement and to compare about the traditional and the machine learning paradigm, how the system it works. And we can show the brief introduction about the interpretable about the machine learning. Here we can see a new paradigm of accurate, trustworthy, user-friendly models. Also, we need to check about the comparison about both these two methodologies, the traditional and also the machine learning prediction. Also, the application building energy management. We need to check what are the fault detection and diagnosis for chiller and air handling units. Also, what are the main advantages and disadvantages by implementing this machine learning in comparison to the traditional method? And the future outlook, it related to the interpretable about machine learning and the popularity to grow in building energy management. Also, very important is to have the data collection. Here we can see one circular about the pipeline, machine learning pipeline, how it works. But starting with data injection, data preparation, after how we can build the model training and deployment, also the performance monitoring. Also, one important part, sorry, just a second, that is. Also, we need to check the circular for implement about the machine learning pipeline. And here we can see artificial intelligence, how that can be implemented. There are four main important tasks. One is supervising learning, and the other parts are focused on the reinforcement learning and also deeper learning data, that we have a lot of data softwares that we can implement. Okay, let's continue. Energy carbon management. This is also related about the sustainable or the developed country. We need to take care about energy carbon management and to reduce the impact in environment, because it's very important. And first of all, we need to check also the data collection and pre-processing. As we can see, gather energy and carbon data, posted for accuracy. We can check implement identification through machine learning, the complex energy and carbon usage patterns. What are the most that can influence the carbon in environment? Also, we need to check anomaly detection, how the machine learning spots abnormal spikes in energy and carbon emissions. Also, the predictive modeling that we can machine learning that can help us for forecast the future energy and carbon needs. And also, we need to check, the final one is related to optimization and control, because control is very important also for the future improvement in the real time about the usage, about the energy, and also the carbon. Decision support system for energy management. Also, we need, here we can see the scheme, how we can implement it, but starting with data set collection till the knowledge use. Till the end. And first of all, we need to collect what are the most usage consumption data from different sources that we have. And also, we need to check the predictive models for energy demand. We need to choose sustainable algorithms for analysis. Also, we need to integrate data and models into decision support system. And in the end, we need to check or to present insight to inform energy management decision. Okay, this is a short and a brief presentation about the implementation renewable energy in almost in the building, because this is one of the most consumed. Industry is also one of the biggest consume of the energy, but also the buildings or all the old style buildings that are consuming too much the energy system, and also impacting the environment through the carbon usage. Thank you very much,
Thank
and
you
we
so
are
much,
open for
dear
questions.
Professor Dehoska. That was very fantastic and fascinating presentation. What is the everyone? If you have any question, just you can ask from Professor Dehoska.
Or maybe in the end, maybe someone in the end, we can collect it all the question and we can make briefly about our workshop, and we can make if someone that don't have now, maybe in the end they can make also the question.
Yeah. What is the
Okay.
next step? We should go to Professor Agus.
Yes. Thank you. Thank you.
Professor Agus, we are at your service.
Okay, thank you. Hello, Professor Claudian Doska. Thank you for my opportunity uh, to be presenter in this workshop. And first of all, I would like to thank for all of you, because I hope I can share my little bit knowledge about workshop on solar system simulation and green building. And would you please share my slide of PPT, Muhammad Gebi? Thank
Yeah,
you.
you have it.
Okay, thank you, Muhammad Gebi, for
Yeah.
share our PPT in this. Maybe in here, I would like to little bit share our uh, probably little bit knowledge, little bit experience for research on solar system simulation and rebuilding. Actually, I make some simulation for not about solar system, but correlated with solar system, I think. On the aim to explore the intersection of two key areas, solar system simulation and green building, within in the context of transition technology trend from fourth industrial revolution industry to the era of society 5.0. The workshop will value into the utilization of solar system simulation, which involves to modeling and analyzes solar energy system, including photovoltaic panel, a solar thermal system, and energy storage solution. We will discuss the latest advanced for simulation techniques, software tools, and modeling methodologies aimed to optimizing the performance, efficiency, integrated the solar system into various application. Furthermore, we'll focus the concept to green building, which priority sustainability, energy efficiency, and environmental responsibility as well. And as part of discussion, I mean, participate will explore emerging trend and innovation in solar energy green building technology, including advanced simulation tools, smart building, integration, energy storage solution, and circular economic and sustainability material, policy and regulation framework. This role of government policy is important because incentive and regulatory framework in promoting the adoption of solar energy system, green building participate. This includes substitute in the in quantifies building code and sustainability mandatory to accelerate to transition low carbon built environment. Overall, the provide of platform for interdisciplinary collaboration, knowledge sharing, and capacity building to drive innovation and progress in the field of solar system simulation, green building, as well as part of broader societal transition toward an sustainability, resilient, and human-centered future environment in the society 4.0.
Professor, pardon, I'm disrupting you. The slides are coordinated with your presentation. Are okay?
Yeah, I think correlated with my presentation in
Okay.
our PPT. I mean,
Okay, thank you.
okay. Maybe we can go to slide number 3. Yeah.
Yeah, here.
Okay. Sorry, number 3. Yeah. One moment, because I can look my
Okay, okay, it's okay. I will.
PPT. This is number 2 or number 3?
It is, I think, it is number three. This.
Number 3. Okay. Okay, number 3. Okay. No, number 3. Uh, in area, this is strategies for addressing control system problem in energy management, focusing on advanced technology and methodology. Is right?
Yeah, it's the
Okay.
small control problem.
Okay, for advanced algorithm, the adoption of advanced control algorithm is proposed to enhance energy optimization within building. For example, this algorithm leverage complex mathematical model and optimization techniques to dynamically adjust energy usage based on real-time data and system parameter. By optimizing control strategy, energy consumption can be minimized without compromising comfort or operational efficiency. For sensor integration, this approach involves integrating a diverse range of sensor into control system to gather more accurate and comprehensive data about various aspects of building operation. The sensor can monitor parameters such as temperature, humidity, occupancy, and energy use in real time, providing valuable insight into building performance and enabling more precise control action. There are one, two, three, four, six about predictive analytics, machine learning. This is so very important because predictive model are employed to forecast future energy demand patterns based on historical in data and external factors such as weather forecast, building occupation, schedule, and unity pricing. For machine learning, I think machine learning techniques are utilized to analyze vast amount of data and identify pattern, trend, and anomalies that might not be apparent through traditional analysis method. By continuously learning from historical data and adapting control strategies accordingly, machine learning algorithm can optimize energy management process in a dynamic and adaptive manner. For the remote monitoring, I think remote monitoring and control capabilities enable facility management and operational to access and manage business system for anywhere, providing real-time visibility into energy consumption and system performance. This allow for timely intervention and adjustment and troubleshooting to optimize energy usage and address an issue promptly, thereby improving overall system efficiency and reliability. This approach represents the forefront of technically innovation in energy management system, offering scale and efficient solution to control system challenge by leveraging advanced algorithm, sensor, and integration, predictive analysis, machine learning, and remote monitoring capability. Organization can achieve either energy efficiency, cost saving, and operational resilience in their building. Next slide, slide 4.
Yeah, you have it.
Okay, slide 4.
Yeah, you are in
Okay,
this.
Okay, the outline the necessary step for optimize energy usage in building, including clearly defining energy optimization goal and performance metric, gathering comprehensive data on energy consumption and building behavior, developing accurate model of building and its energy system, selecting appropriate advanced control algorithm for optimization, fine-tuning algorithm parameter for specific building condition, integrating algorithm into exciting building management system, implementing real time, for example, feedback loop and dynamic adjustment, and finally adapting algorithm over time to accommodate change building usage of environment. Next slide, slide 5. Okay, slide 5. To create effective energy management strategies considering implementing the following approach. For example, for model prediction control, MPC, utilize predictive model to optimize operation, ensuring energy efficiency while maintaining a comfort level. And demand side management, DSM, actively manage consumption pattern to reduce overall demand and associated costs, and optimizing and then efficiency for adjustment system using advanced algorithm tailored to specific need and condition. And for detection and diagnosis, VDD, for example, implement system to detect fault prompt, allowing for timely maintenance and minimizing energy wastage. By incorporating in these strategies, organization can optimize energy usage, reduce cost, and enhance overall sustainability. Next slide. Six. So let's take, okay. Model predictive control, MPC, elaborate on various aspects related to prediction method and their application. Prediction method, for example, three main approximations are employed for energy forecast. Physics-based with BOG, for example, this model utilize fundamental principle and equation to predict energy consumption. Data-driven, black box, for example, this is a statistically evaluation and artificial intelligence techniques are employed to forecast energy use based on historical data. Hybrid, the name gray box, for example, this model combine element of both physics-based and data-driven approach for more accurate prediction. For the building energy consumption prediction, this is a different modeling technique are used based on the prediction method. With bulk model, for example, utilize physical calculation for forecast energy consumption in building. For black box model, rely on statistically evaluation and artificial intelligence algorithm to predict energy use pattern. And application of black box model, this model are applied in predictive control system for boiler, for example, for managing peak load and integrating renewable energy source in building operation. And finally, application of gray box model. The gray box model are predominantly used in a non-residential building to optimize airflow, estimate the ventilation rate, and developing thermal building model. And slide 7.
You have it.
Next. Okay, for DSM, demand side management, this is about energy management involves several key aspects. For example, DSM aim to enhance energy system for the user perspective and pacing effective pricing structure and real-time management to optimize consumption. For the DSM encompasses two main strategies: demand response, which involves adjusting energy usage in response to grid condition or pricing signal, and energy efficiency, which focus on reducing overall energy consumption through various means. For integration of technology, the ISM integrate a variety of technologies such as renewable energy generation, energy storage system, smart device, and advanced method to create more energy efficient building and system. For energy efficiency studies, this research in energy efficient explore topic like smart metering to track and optimize energy usage, assessment electrical behavior in identify inefficiency load estimation for better resource allocation and utilize of thermal mass to regulate building temperature efficiently. Demand response studies, it is about to reduce peak load by implementing strategies such as and use control to adjust energy consumption during peak period, cost reduction through optimized usage, implementation of smart home energy and management system. And overall, DSM play a crucial role in optimizing energy usage improvement efficiency and reducing cost through a combination of demand response and energy efficiency measurement, supported by the integration advanced technology and insightful field. And next slide for the slide ideas, optimizing energy management encompasses several key points. For example, optimizing approach energy management system optimizes a plot of various approach to address different objectives across different conceptual level within the system. For the data uncertainty, optimization in energy management confront for challenge of dealing with attention that for employing robust and stochastic and optimization technique. And for static optimization, this is operate under the assumption of no or estimate probability distribution. They primarily focus on minimizing power assumption and enhance energy efficiency and predicting load demand. For the robust optimization, uncertainty within a different set of parameters, the object is to achieve optimization planning, effectively management comfort level, and coordinate energy usage will ensure consumption and not violate. And studies and application for these conditions that studies employing method priority maximizing comfort and energy efficiency. Conversely, and technique are applied to achieve optimal planning and efficient system on management. And the last slide, slide 9. This is about fall detection and diagnosis. FDD in energy management highlight the following key point: import, importance of FDD, efficient execution in energy management system. I mean, it is crucial to prevent energy loss and minimize operational costs. And fall detection and diagnosis, this is main play for vital role in identifying and insulating flow within building energy management system. There will be safeguarding system for further damage. And for type of FDD technique, I think are categories into knowledge driven and data driven approach. And data driven approach is a approach leverage artificial intelligence to analyze monitoring data, focusing on detecting abnormal pattern indicate of fault. And knowledge driven approach, this is about method really on expert knowledge to effectively detect for fault particularly in scenarios involving incomplete or uncertain data. Application of FDD, I think studies concentrate on identify fault cause in heating system and detecting irregular operation pattern and conducting analysis for handling unit. And limitation and contribution for this technology, both knowledge driven and that drive approach are predominantly applied in non-residential building and system, and research by within the knowledge driven approach will data drive approach and combines in building system. I think this important of FDD in energy management, showcasing how different approach and contribute to identify and addressing fault to enhance system efficiency and performance. So thank you for your attention. Hopefully it is useful for your knowledge. Thank you.
Hey, thank you so much, Professor Promono, and thank you for your time. That was very fascinating and useful presentation about the energy system management in building. Everyone, if you have any question from the Professor Pramono, you can ask, and if you don't have it, or maybe after presentations, you can share it with us. Okay, thank you so much, Professor.
You're welcome.
Okay, I think El Hadi, are you ready for your presentation?
Yes, yes.
Okay, we will be with you. Thank you so much for your very nice presentation, and we are waiting to hear about you. Okay, you can share your screen.
Right now I'm sharing it.
Thank you.
Uh, I'm gonna reconnect for a bit because I am having trouble sharing my screen.
Okay, if you want, we
I
can
will
go.
do it right now, okay?
Okay, okay.
Maybe like the other guys can present their PowerPoint and later I will do mine.
Okay, okay, okay. We will do it now.
Thank you.
You're welcome. Okay, everyone, I will start to present my. Excuse me, Al Hadi, can you turn off your share? Okay.
Yes.
First of all, I will say that thank you so much for presenting everything by Professor Agus. Dr. Claudian, I'm professor from Norway, and thanks from El Hadi about his presentation. I should mention something about or institute TULTECH first of all before my presentation about some simulation by the PV system about the solar system in building as green building approach. We are a knowledge-based company as NGO and we are non-profit in the Estonia under the environment of Europe, and we are working in three different branch of works. One is events, such an event that you can see here, and conferences. This year we will have at least 5 different conferences under Scopus, Web of Science and everything. And also another one is research department. After this meeting and workshop, if you want to participate and collaborate with us about European projects and applying for different European projects, please let us know, and we will be happy by any collaboration in different branches of the science. Specifically, this year we focus on energy and environmental issues, which are a hot topic in Europe. Another, the last branch of our institute is publishing department, and in publishing department we have four different journals. In mostly they are multidisciplinary, and one of them is completely multidisciplinary. Another is computational, social, and human-based science, and another is in the field of environmental engineering and environmental science, and another energy. Just I wanted to introduce our institute to you, and we will be in touch with you after this meeting, and we will be happy if you would like to collaborate with us, specifically in the project and project preparation for European calls. Okay, today after the presentation of all professors from Indonesia and Norway and Albania, about the frameworks and different aspects of solar energy, about the experiments and simulation modeling. Now I want to present something about how we can simulate this approach in buildings by PVC software. And as an example, I will mention one project that we had with one company in UK, in Plymouth City, in I can say south of UK, and you can see the results of the simulation and outcomes that we have presented there. Okay. Before I introduce myself, my name is Muhammad, and my last name is Qaibi. Originally, I'm from Iran, and now I'm CEO and head of research department at TULTECH Institute in Estonia. And as introduction, I should mention that why PVC software? Why we cannot use another software? You know, when what software is more popular in comparison of other software for using in a specific field of science or engineering for simulation? It is related to the volume of feedbacks that they received from other users. For example, you can imagine that there are more than 20 different softwares that you can use for simulation of solar system in buildings. But how we can understand which of them is the most popular and valid for using based on the huge number of feedbacks and users that they send feedback to the company. And PVCs is one of the most popular software in this field. And in this field, you can specify your power or area. For example, in different countries, in European countries, countries in Asia and America and different regions, there are different rules based on supporting the government or private sectors from the solar system production. If you want to evaluate it somewhere, they are evaluating the energy system based on the area that you can use, and another one about the capacity of energy. Both of them are defined before in PVC software, and it is in the following I will show you. And it is the main point of using PVCs as a flexible software that you can use it. Another one is the library of different panel companies that you can use. For example, in the photovoltaic system that you want to implement and design and then implement, you need to know which company's panel can be used for this. And it is the main point and the score of the software that you can select different companies, famous one, and it is updating during the time. And also you can import some data about new company based on the specification that you have to the software, and you can use it based on your local region. And the final is inverter, an internal inverter and connection between inverter and photovoltaic panels is another issue that it is met in this software. Okay, in the following, you can see the first step when you want to use PVC software. All the presentation that you can see in this meeting will be shared with you in our website, and by email you will be announced about it. First is related to determination of the geographical zone. It is very important because with the using meteorological data sets, it is connected to the software online. If you are using the main version of the software, no demo one, by using connecting to the internet, everything will be updated by this software. Okay, after finding the specific place that you want to use it, for example, you can see here in the region that we programmed before, it is related to Polymos in UK, not important here. It is the first step in the beginning of the software that you want to use. And another step is related to project setting. It is very important. The first step in the project setting is albedo setting. What is the albedo? In albedo is the very simple physical model about the interaction between reflection or receiving the radiation from solar or from the source of energy that is that has a specific radiation to the different mass, a specific black mass. It is the main theory. There are lots of formulation behind it. I don't want to open it, but totally you can imagine that here in the left picture you can see that the albedo coefficient is different in different types of material that you can see here. For example, dry asphalt or red tiles or aluminium or something that you can see in the cities, they are different. Okay, when you want to pardon, when you want to simulate something in the software, in my opinion, based on my experiences that I simulate some different regions before, you should trust to the defaults of the software in this step of simulation. But if you have a specific city, for example, you have one specific city that is very far from typical architecture of other cities in the specific, for example, in Saudi Arabia, we heard that they are creating a specific city with a specific architecture. Okay, in this in this region, we should adjust our coefficient based on, for example, if everything there are from glass, we should adjust from the coefficient of glass. But if you don't have it here, you can see that the common value is 0.2, and we can use it. Another section that we have here, it is about the specification of temperature interaction in voltage limit or usual operation temperature or summer. It's very important, winter and summer operation temperature. But again, I'm telling you in this section, if you don't have, for example, in about one country, for example, in Middle East country, for example, my hometown, Iran, you can imagine that in the south of Iran, the temperature is very high. It's very high. And if you want to set it, you should change it in the winter, in the summer, or in the moderate condition of temperature that environment could not change the equipment condition. You should not change these parameters during the simulation. Okay, what is this section that I want to talk about? It is, in my opinion, it is one of the most important section of the simulation in the PVC software. You can see here there is the name is orientation. In the orientation, you can see here we have two different features that we should set. One is plane tilt and another is azimuth. Both of them are very important, but in my opinion, and again based on my experiences, plane tilt is the most important. Here, if you imagine that this shape that you can see here is the panel, you can see the different, for example, if we have three different lateral environment, and in which of them angle of this plane in each of them has a specific name. For example, you can see tilt in between the axis of north to south, and angle is there which is named tilt. Okay, how we can adjust the tilt? We should adjust the tilt little by little when this value that you can see here, loss by respect to optimum, will be equal to zero. It is very, very important. Specifically, when your support is fixed, because of the energy issues and maintenance issues, the most operators and designer prefer to choose the fixed support for solar system, not moving, because also some technologies there are for tracking the solar and finding the best condition of this panel based on one specific electromotor for finding the best location in each hour. But based on the operation and problem that you will have in the maintenance of the system, someone mostly they are preferring to use the fixed one. Okay, in this condition, tilt will be important. You should play with try and error method for finding the zero loss by respect to optimum value. And here you will have three different features that you can see the loss is changing in these two figures. One is yearly, another is summer, because you should, for this condition that you want to compute the energy global and collector plane, or the loss by respect to optimum, you should know the intensity of solar radiation, and the condition of summer, winter, or average of yearly is completely different. But it is up to you. If you want to use the solar system for some specific mission in period of time, in summer you can use summer, or winter you can use winter. But it is related to your region. But totally, if you want to see by holistic view to this project, we should use, if we are using all the yearly, if we are using continuously. Another feature that we want to talk about it is the grid system definition. It is very important. Take a look to this picture. You can see here we will have two different criteria. As I mentioned before, first is the capacity of energy, and another one is the area that you have. For example, if you want to implement the solar system in the roof of one specific building, you need the area. Area is very important because maybe you want to use the all capacity of area that you have. And if no, for example, in the one flat area and you don't have limitation, you want to implement this system, the providing the energy and cost issue is important. Here there is two different windows that you can see. The first one is related to photovoltaic modules. In the photovoltaic modules, as I mentioned before to you, you can use the company and the type of panel that they have in the company, and you can use a specific panel. For example, if you are in the India, if you're in India, maybe some of these companies there are, or in India or Pakistan or China, there are some different local companies there. Or in Europe, maybe there are new local company, and you can add some information about them to suffer for modeling. Okay, and another one is the inverter specification. It's very important because there is one relationship, a formula for finding the inverter capacity based on the panel that you are using. And here, based on the oversizing factor, which is defining between 1.1 to 1.5, you can find the exact value of the inverter and the capacity of inverter, and you can use it. Okay, here in each simulation you will have one error if the photovoltaic panels and your inverter are not paired together, and you should remove, and for changing with try and error, changing different, as my experiences, again saying to you, I'm telling you, in my opinion, first, based on the local condition of market that you have, first set the panels that you want to use, and then in the next step, based on try and error, find the inverter, because the variation of different inverter are more available in market in comparison of the panels. And finally, for example, I'm coming here in the second picture that you can see here, you don't have any error and everything is okay. And after pairing the inverter and panel, you can see that in this software you will have one arrangement. How many, for example, in this system that you can see, the number of modules are equal to 30, and with 30 the arrangement of software is very important, because for example it is in 15 series and 2 strings, and in the following I will say to you why it is very important. Okay, here, after finalizing everything, and in this picture that you can see in one website, we will share it with you. In SunCalc, you will have the altitude and attitude of the solar, the sun, about your location that you want to design your system there. If you in the software, if you go to adjustment of horizon line drawing, you can based on a specific tilt and azimuth that you used before, you can add from the SunCalc software website, you can add the attitude and longitude and latitude, your region in comparison of the sun, and then finally your model will be calibrated. Why? Because, for example, in the cases that we did in Polymos, here you can see this area, for example, between this hour to this hour, you can see it is the main area that you want to, you can use the energy. Theoretically, maybe there are more energy that you can obtain, but what is the difference between bad and good simulation? The good simulation is simulation that can interpret the outputs of the real feature, and here with this calibration you can find it. Pardon. Finally, you can simulate the software, and the simulation you will have the collection in the energy availability in different months, specifically in this software. You will have it. You can adjust it. It is flexible in the software, hourly, daily, monthly. But for managerial insight, maybe monthly will be more sense. Will have more sense. And here you can see that the outputs of the simulation that available here. But why I said to you the arrangement is very important. Why the arrangement is very important? Because you can see that the parameter that we adjust before, that was just initial parameter, tilt and azimuth and a specification of panel and inverter. But here, in the next step, in the 3D modeling, you want to see the most important parameter in the solar system simulation. It is shadow. Shadow is very important. Why? For example, here you can see one panel. In one panel, one part of panel, there is shadow in one specific part of panel, but it is the behavior of energy, electron transfer during the this silicon structure of the solar panel. If you have shadow, even in 25% area of this panel, you maybe in this some condition based on the panel type and the material that is used in the inside of the panel, you cannot provide any energy, and it is disaster. And because of that, here, based on the series that software suggested to you based on the previous step here I mentioned, you should model it for what? You should model it for adjusting some other features. For example, uh, vertical distance between panels, or horizontal distance between panels, or baseline, in another lateral that you have in the 3D environment of the panels between together. You will play with try and error based on the area that you have, because it's very important. Everywhere, for example, in a specific roof of a building, you don't have for example, more than a specific area, and you cannot use it. But what is the most important here that I wanted to mention to you? Based on the one global contract between people that they are simulating the solar system, here you should simulate the system as I did here. You can see in the 21st of the December. Why? Because based on some geographical and physiogeographical analysis in the solar system. The solar will be in the highest location in comparison of Earth in the 21st of December. And because of that, for the simulation, for finding the loss during this issue, for worst case scenario simulation, you should choose 21st of December. And as the main output of this software, you can see that you will have the kilowatt hour per day. It's very important as a managerial insight that you can provide for them, because based on this information, you can find that, for example, if you have a microgrid system in a specific industry, you can find that, for example, which day, how many you will have loss, you will have energy, and how much you should provide from on-grid system that you have. And sync and source of this needs a specific programming and field of study that some researchers they are doing. And another diagram that is the output of this software, and it's very important, it is different loss. And the losses, you can see the different losses during the simulation. And for example, losses based on the temperature, based on the warming of wires, based on the problem in the collectors, based on the efficiency, because there are different. If you are using the amorph one or crystallic one, completely they are different. And then the crystallic one, they are more efficient, but they are very sensitive. In summer, for example, in some region in Europe, that you have lots of rain, and the sun value is very low. With crystal one, and you have different very cold temperature, maybe you will have problem with silicon one. But if there is for example smooth changing of temperature in everywhere, you can use the silicon one. But totally they are using amorph because of changing the high level of changing temperature in different season. The last slide that I want to present to you, that is very important if you want to research about different issues and topics, is carbon and economy. Both of them, carbon and economy, both of them is very important. Carbon because of the eco-environmental analysis. Carbon, you can see the diagram of carbon in this software. If you are going to manual of this software and read about it, you can find it based on the energy, renewable energy availability that you can have by this software. It will compare with the fossil fuel, and therefore you can find that how much carbon you can prevent for releasing an emission to the environment. And finally, about the economical analysis, about the different metals that first, what is the most important issue here? I think that is you can adjust the currency. If you are in India, you can adjust is the rupiah of India. If you are in I don't know, for example, USA, it's the USD, you can adjust it or everywhere. In this feature, in the life cycle cost of this solar panel, you will have the data, the final data after which year. It is very important because managers just they are asking after how many years using this solar system, specifically in the Middle East, because if you are in Europe or USA or Western country or more Eastern countries, the price of energy is very high. And for example, after 1 year you establish this solar system, it can be costly for user because if you wanted to use on-grid energy, that was very expensive for you. But in this condition that you are using this, it's valuable. But the long of the cost benefit balance here in Middle East countries that they have oil and the energy price is very low. For example, after 10 years or 8 years, based on the energy and policy that they have in their countries, each of them, it is different. Thank you so much for consideration to my presentation. If you have any question to me, just ask me. I will at your service.
Thank you, Mohammed, for the nice presentation. I think maybe we can make an overview in the end of that one. And
Yeah,
okay, let's continue with El Hadi.
yeah.
Pash. I think we don't have more presentation after El Hadi, or we have it?
No, we don't have it as
Okay,
as
we
we
don't have.
finish. Yes.
Okay, okay. It's your turn, El Hadi.
Okay, hello everyone. I don't know if you can hear me well. Can you hear me?
Can you hear me? Can you hear me? Can you hear me? Can you hear me?
So,
Can
uh,
you,
I,
El Hadi,
I,
please share the slides, or because it's not open yet.
I'm sharing the slides. Can you see them?
No, no, we can't see.
I'm trying again.
Mohammed, please, can you help about sharing the slides, or maybe
Actually,
you
let
have the
me
presentation of El Hadi. Maybe you can make share there.
give me time, please.
Yes, it is better if Mohammed
But you
can
have
do it
here
because
the present now. You have one icon in the bottom. That is,
Okay.
you have the hand and you have also the.
Okay. Okay. Let me.
Okay, just.
because I don't have a webcam on my laptop and I cannot do the presentation. So I'm trying to share from both of my accounts, but
Okay. Claude, pardon. Can you send it to me again because no, I have problem for finding this. It's in my spam.
okay, I'm sending to you right now.
I don't know Reza is here or not. Reza, can you share it?
I forward it again to you, Mohammed, the presentation.
Okay. No, I will share it with you.
Okay, thanks.
You're welcome. Can you see my screen?
Yes, right now is okay.
Okay.
So I have done an overview of solar system simulation and green building software, where I have shown the advantages, and also I have shown the perfect tools to design green buildings. Uh, so first I will explain what are solar system simulations. Solar system simulation are computer models that replicate the physics of our solar system, and with this solar system simulation, we can have 3D models of them of the solar system, and we can make uh, perfect alignment calculations to get the most
Sorry,
efficient
Mohammed.
way
Sorry,
of using them.
Mohammed. Can you share again because it's disappeared. The slides are not showing yet.
Yeah, I don't know. Can you see? Pardon, I think I have a problem here. I don't know why it is not working in my system. I cannot hear you, Claudia. Okay, if what's your idea? If you agree, uh, El Hadi can present something.
I will try to present it again by my PC.
Yeah, I don't know what is the problem of the PowerPoint in my system. Okay, Claudian, Claude, Dr. Dihoska, can you hear me?
It doesn't hear. So I'm, I'm trying to present it from my other email.
Okay, I think, pardon El Hadi, I think,
Not a problem.
yeah, I think there is a problem now and we cannot hear Dr. Dihoska, unfortunately, because of this problem. Uh, Thank you so much for everyone that you participated in this meeting. And no, I wanted to say thanks to you. Uh, if you want to be in touch with our institute and with us, please let us know by email to the TULTECH website. You can go and uh, sh- share something with our institute. Thank you so much from everyone, and have a good day.
Thank you, Mohammed.
Bye.
Also, thank you to Ishu, to Jagdep, and the others. Also to Shabnam for
Yeah.
attendance. And thank you for everything, Mohammed, Reza, and for all the presenters.
Yeah, and thanks to El Hadi, and so sorry because of this problem that happened. I don't know.
Not a problem. Not a
Yeah,
problem. It's
we
okay.
will be in touch with you. Thank you.
Okay, Mohammed, please also you need to prepare the certificates for all the participants and
Yes,
presenters
yes.
and sharing via email.
By email, we will be in touch with all of you and
Okay,
also send the
Okay.
certificate to all
okay.
persons.
Thank you very much, and have a nice day to everyone.
Okay, thank you.
Thank
Bye-bye.
you, Professor.
Thank you,
Bye.
Agus Pramono. Thank you. Bye.
Professor
Thank you.
Augusto, bye.
Bye. Thank you.
Bye bye.
Bye.